This one's going to wrap up our types of probability models. We've talked about Bernoulli, geometric. Today we're going to talk about binomial. And the key to understanding which one to use is to understand what each model tells us. So let's find out, what does the binomial model tell us and what are some assumptions? So we have the same starting assumptions as Bernoulli. Independent trials and success and failure are the only outcomes. One thing cannot change another, so our probabilities are not going to change. And our key to this one is going to be that the binomial model is going to tell us the probability that a certain number of successes will happen after a certain number of tries. So in our geometric model, we basically could find out the probability that a success happens after a certain number of tries. This, we can ask for a certain number of successes with a certain number of tries. So it's more specific and what I would argue a little bit is stronger. So let's take a look. What is our formula? So R is going to be our number of successes and N is going to be our number of tries. So that gives us this formula, NCR. We've already done combinations. It tells us that the order that we get our successes in doesn't matter. P is our chance to success, and Q is our chance of failure. So let's dissect this formula. So if I want, say I have 10 tries, and I want 3 successes, well then R, well that makes sense, I would have 3 right here. Well then, if I have 3 successes, that means I have 7 failures. And this is telling me that order, do you remember, order does not matter. Yeah, I messed up order over there. Order does not matter. All right, so our expected value is going to be N times P. So that's our number of tries times our chance of success. Our variance, NPQ. And of course, our standard deviation is the square root of that. Okay, so let's take a look at an example. So the chance of getting a legendary Pokemon is 15%. So if you have a pack or something, the chance that is in there. So what is the chance of getting 3 legendary Pokemon after 12 tries? So notice how that's worded different than the geometric. Like we get a certain number of tries and a certain number of successes. So our number of successes is 3. And our number of tries, N, 12 tries. If you try 20 times, oh wait, I'm jumping ahead here. So what is the chance of 3 legendary? So we're going to do this. This is NCR, P to the R, Q to the N minus R. So I have 12 tries. That's 12 C3 times 0.15 to the third times well, what's a failure? Well, a failure, if this is a success, a failure would be 100% minus the 15%, so 85%. So 0.85 right here. I took 12 tries, so that means 9 failures. So let's go ahead and bring up the calculator. You're going to want to have that probability mode ready to go. So find out where your calculator stores the NPR, NCR kind of stuff. So I'm going to put parentheses right here. And I know that it is under probability on my calculator. And there's my NCR. So I want 12. And of those 12, 3 of them will be a success times 0.15 to the third, and then 0.85 to the 9th. Put that in. And 0.17. Or a 17% chance that that happens. If you try 20 times, how many legendaries can you expect to find? So our expected value, or our mean, is NP. So I take 20 tries, and then times my probability there. And if we were to type that into our calculator, we would get 3. So we expect 3 successes in after 20 tries. It asks then for the variance in standard deviation. So variance is NPQ. So I basically am just going to take my mean and multiply by the chance of failure. And I get 2.55. So that's my variance, which means my standard deviation is the square root of that. So it's going to be the square root of 2.55. And if I type that into the calculator, I get 1.6 about. What is the chance of getting 2 legendary Pokemon after 15 tries? So N is 15, and I want 2 successes, so R is 2. So 15, choose 2, times chance of success, 15, 2, and 0.85. Well, then there will be 13 of those. So what's that equal? Let's bring up the calculator again so you can see what I'm putting in. So I'm going to find my probability menu, and I'm going to put in 15 tries, 15, choose 2 of them, times 0.15 to the 2nd, and then times 0.85 to the 13th. And we get 28.6% chance that that will happen. Now, this is specific. This is exactly 2. So this would not count, say, if you got 3 or 4 or something more than what you were actually looking for. So suppose there are 20 people in line to donate blood, and there is an 8% chance someone is O negative. So what is the chance that 2 of them are O negative? Well, that is going to be 20, choose 2, times 0.08. That's our chance of success. 2 of them, so 2, and then 0.92 chance of failure to the 18th. Okay, so we'll put all of that in. So I'll go ahead, 20, choose 2, 0.08 squared, and then 0.92 to the 18th. 27.27. So 27% chance that 2 of them of 20. What is the chance that 3 of them? So 3. Same number of trials because I have 20 people in line. What do you think? Does the chance go up or down? We'll find out here shortly. Wish this would just stay up, but that's okay. 20, choose 3, 0.08 to the third, 0.92 to the 17th, 14%. Okay. What is the chance that 2 or 3 of them are O negative? What do you think you're going to do? Well, you're going to add these two, right? So you're going to have 0.27 plus 0.14 gives us 41. So 41% chance that we get 2 or 3. We add those two. Suppose 200 people are in line to donate, and there is an 8% chance. How many can you expect to be O negative? So our mean is NP. So we have 200 tries and 0.08% of them. So it's basically 8% of that 200. I won't bother bringing up the calculator. I'll just type it in here, and 16. So we expect 16 of those 200. What's our variance and standard deviation? Our variance is going to be in PQ. So I'm going to multiply my 16 times 0.92, and I get 14.72. And my standard deviation is going to be the square root of that. So I'll go ahead and square root that, and I get 3.8. All right, I think we have one more example of this. The chance of a car getting in a wreck on a certain portion of highway is 5%. Of 40 cars, what is the chance that 1 or 2 of them will get in a wreck? So I'm going to set it all up right here. So we have 40 tries, that's our N, and 1 or 2 successes. So we have to do this twice. So we'll have 40, choose 1, times 0.05. So a success in this case is someone getting in a wreck, to the 1, and 0.95 to the 39. Then plus 40 choose 2, so 2 of them, times 0.05 to 0.95 to the 38. Now, it's possible that our calculator will not actually do this for us, or at least not nicely. So let's go ahead and find out. What it will say. So we are going to do 40, choose 1 of them, times 0.05 to the 1, so I'm not going to need to write anything there, 0.95 to the 39. Now I'm just going to add the plus right here. 40, choose 2, 0.05, this time squared, 0.95 this time to the 38. We'll see. I'm expecting scientific notation, but we'll see. Oh, no, it came out all right. All right. So I hope I typed that in right. Oh, well, well, we get I forget what that actually said. I think it was 54. So a 54% chance. That was pretty high. Well, we get 40 tries, so let's see. If I did not ask for the expected value, but let's see. What's my mean? So 40 times our chance is 0.5. So if I type that in, 0.05, sorry, 0.05. So 0.05. So my expected value actually, my mean is 2, which is why this is so high. So if it had been something else, this would probably have been lower. And the reason I was expecting something low was actually because of this 40, choose 1. All right, so, or these decimals, I mean, I should have said because of that exponent right there, pretty high exponent. All right, so 40 cars, what is the chance that 3 to 5 of them get in a wreck? Well, I'm not going to necessarily do all this and type it all in, but it would be, this is what we would ultimately be doing. 0.05 to the third, 0.95 now to the 37, now plus 40, choose now 4, because it's 3 to 5 of them, 0.05 to the fourth, 0.95 to the 36, plus 40, choose 5, 0.05 to the fifth, 0.95 to the 35th. And you would type all of that in, or do it in little pieces, and in the end, add them all up, and that will give you the chance that that happens.